From what I could tell, AMCs are the next Olympiads that are going to come up, other than Yuzuko, of course, but I've done plenty of Yuzuko videos. I have not been doing enough math content, okay? Don't worry, I'll get through the other gold problems, hopefully next week. I'm sorry if it's not in time for the Yuzuko competition. I think I'll be able to get one more gold problem out before the next Yuzuko competition, so hopefully that helps. But today we are doing math, and today we are going to be doing the 2020 AMC 10B. Hooray, let's do it. I have not done math in a while, so we shall see if I am still worthy. And also, by the way, I will do FMA after I do one more Yuzuko gold video. It should be epic. Okay, put the timer on for 75 minutes and let's get started. Epic. Okay. Number one, what is the value of just 1 minus... Oh my god, why, dude? Why you gotta do this to me? 10... 5, okay. Bruh. 1 is D. Hopefully I am good at arithmetic, but that is a very hard assumption to make. Okay, problem 2. Carl has 5 cubes, each having side element 1, then she has 5 cubes, each having side element 2. Wow, holy moly. Total volume, 8 times 5 plus 1 times 5. Oh my god, that is 45. So that is E, alright. The ratio of W to X is 4 to 3. W over X is 4 to 3. Ratio of Y to Z is 3 over 2. And Z to X is equal to 1 over 6. What is 1 W to Y? So if we divide these two, we get 8 over 9, right, is equal to W over Y times Z over X. And then if we substitute 1/6 for that, then we just multiply and we get 16 over 3, and that is cool. So E. 4. Acute angles of the right triangle are A and B, where A is greater than B. So we got a 90-degree angles. Okay, A and B. And they're prime numbers, so we basically want B to be as small as possible, I can speak. So essentially we want 90, so what's the biggest prime? 90 is 89 prime? Please tell me. Yeah, I think it's prime, but 1 is not, so then we could do 87 is not prime. 85 is not prime. 83, is that prime? Probably. So 7 seems legit. Okay. Hey, the first 4 are D, E, E, D, deed. I think Aops intended that, right? It must be. Alright, problem 5. How many distinguishable arrangements are there of 1 brown tile, 1 purple tile, 2 green tiles? They're okay. Wait, what? Is it not just like, okay, so how many are there total? 1, 2, 4, 7. So 7 factorial over 2 factorial, 3 factorial, right? Okay, that is just 7 times 5 times 2 times 3 times 2. I don't know why I did that, but that works. Okay, so 20 times 21 is equal to 420. Hey, very nice. Bruh, AOPS is really memeing. I see how it is. Well, not AOPS, MAA. Problem 6. Driving along a highway, Megan noticed that her odometer showed 15951. Nice. Palindrome reads, okay, 2 hours later, they do the next highest palindrome, so that would be 16061, right? How much more is that? That is 111 more? No, 110 more, okay. So 110 over 2 is just 55B. Nice. How many even multiples of 3 less than 2020 are perfect squares? Positive even multiples of 3. So just multiples of 6? No, that's not necessary. Wait, what? Is that true? Yeah, it is multiples of 6. So less than 2020 are perfect squares. So basically you want to find how many multiples of 6 are perfect squares, and because 6 is 2 times 3, like, if you want like a squared to be divisible by 6, you need a to have a 2 and a 3. So basically a is divisible by 6. So essentially, the biggest square, less than 2020, that is divisible by that should be 44, right? Because that's like 1964 or something. I don't know the exact number. But then, it's just number of multiple of 6 that are less than that. So just divide that by 6. That should be 47, right? So there should be 7 multiples. Is that right? Should be 7, right? I might be trolling, but I think that's right. Hey, P and Q lie in a plane with PQ is equal to 8. Alright. P and Q, that is 8. How many locations for point R are there such that the triangle with vertices P, Q, and R is a right triangle with area 8 units? Okay, so basically the thing you gotta know is if, oh, wait. Oh, so obviously it can rely on the circle with the diameter of PQ, right? Because then this is going to be a right angle, right? So if this is the case, then we want this, how do we do this easily? So essentially we need the height to be 6. So we need this height to be 6. So if that's 6, the radius is 4. Wait, what? Is that even possible? No, it has to be 3. That has to be 3. So this is 3, this is 4. So that's 1. So there's one location, there's one location there, there's one location here, there's one location there. But we could also have PQR like that, right? So then this would be 3, right? Then that would be 3, that would be 3, and then that would be 3. And those are all also right triangles. So we can either have the angle right at R, it could be right at P, right at Q. So I think we got all the cases. And that is 8. 8 options. Okay, so D. Bro, answer to 7 was 7, and answer to 8 was 8. Very cool. Problemo 9. How many ordered pairs of integers x, y satisfy the equation x to the 2020 plus, oh god, I hate these. Okay, so I think, okay, I kind of see like x to the 2020 plus like y minus 1 squared is equal to 1, right? Did that help at all? So you got sum of squares. Sum of squares is nasty though. What's the point of that? Well, okay, so you basically know that both of these are positive though. Oh, big brain. Okay, so let's say x is 0, right? Then you basically have y minus 1 squared is equal to 1, in which case y has to be 2 or negative or 0, 2 or 0, right? Then if x is equal to 1, right, then we basically have, this is 1, this has to be 0, so y has to be equal to 1, right? So this is x is 0. Then x can't be 2 because then the left side would be 4 and there's no way to decrease it with a positive term, so that's not going to work. Then x could also be negative 1, right? In which case, same thing, 2 or 0. Or sorry, y has to equal 1, right? So in that case, our answer is just 2 for this guy and then 2 more, so 4. Okay. 9D. A 3/4 sector of a circle with radius 4 inches along its interior, that is how we do it, is a 2D net that forms a lateral surface of a right circular cone. Okay, what is the volume of the cone? So basically the idea with these ones is that you know that 4 is a slant height, right? Like in your new cone, this is going to be your slant height. And then we basically had to find the radius, right? So we basically find the circumference of this, which is just going to be 8 pi, right? 8 pi is the circumference of the whole thing, so times 3/4 is going to go 6 pi, so this is 6 pi, which means that our new diameter is going to be 3, right? So if that, using Pythag, we have 16 minus 9 is root 7, so that's root 7, and then we basically just do 1/3 pi times 3 squared times root 7 is equal to 3 pi root 7, which is C. Nice. Okay, Mrs. Carr asked her students to select 5 of the 10 books to read on her classroom reading list I could speak. Harold randomly selects 5 books from the list, and Betty does the same. Okay, what are the probability that exactly 2 that they select are the same? So basically the number of ways for them to choose of the 10 is 10 choose 5 times 10 choose 5, right? And then exactly 2 are the same. So we could choose 5, choose 2 of them to be the same, right? Or no, 10 choose 2 are the same, right? 10 choose 2 are the same. Then we had to choose from the remaining 8, we had to choose 3 that are unique to Harold. And from the remaining 5, we got to choose 3 that are unique to Betty, right? Is that right? Yeah, okay, that should be fine. And so, okay, so this is just over 10 choose 5. So, what gets canceled out? This is going to be nasty. Okay, let's do this. So we got 10 times 9 over 2. We got 8 times 7 times 6 over 2. Or 3 times 2, which is 6, which that cancels out. Okay, then we have 5 times 4 times 3 over, no, that's just 5 times 4 over 2, because it's 5 choose 2. So then we could cancel out this there. Okay, so this is still 5. Remember that. And then over 10 times 9 times 8 times 7 times 6 over 5 factorial, and we do that twice, so square that. So this whole thing gets canceled out with this whole thing. Then the 5 has to get canceled with something, so we could cancel out the 5 and just make this a 2. So then it's 5 factorial in the numerator, so 5 factorial squared over 6 times 6 times 7 times 8 times 9. So we basically have 2 3s, so this becomes 5 times 4 times 2 squared, right? Then we have 2, then make this 3 times 3, we have 4 squared, so that's just going to be a 2 in the numerator, this gets rid of that. And we have 5 squared times 2 over 9 times 7, so that's 50 over 63. Oh god, wait, what? Did I miss a 2? Okay, so it's probably D, but I probably messed something up. Okay, so let's try again. 10 times 9 times 8 times 7 times 6, what, over 2? 8, okay, over 6 times 5 times 4 over 2, over 10 times 9 times 8 times 7 times 6, 10 times 9 times 8 times 7 times 6. Why am I spending so much time on this? Okay, over 5 times 4 times 3 times 2. Okay, so this gets canceled out, right? Okay, this gets canceled out, this gets canceled out, and what else could we cancel out? So let's just cancel out the bottom stuff. So 5 and 2 cancel out this. This becomes 2, and this gets canceled out, okay? Then we could take a 3 and a 2 right here, get rid of that. 4 and a 2, get rid of that. And, oh yeah, so it is just 25 over 63. I probably made some arithmetic mistakes, so it is D. Epic. The decimal representation of 1 over 2 to the 20 to the 20 consists of a string of zeros after the decimal point, followed by a 9, and then several more digits. Okay, how many zeros are in that initial string of zeros after the decimal point? So, essentially, this is 1 over 10 to the 20, so those are all going to be zeros, so 19 zeros by that, right? Because, like, if you have 10 to the negative 1, it's 0 zeros right of the decimal point, right? It's like that. Okay, so 19 because of that, and then 1 over 2 to the 20. So now this becomes a little bit annoying, because we have to do some guesstimation, right? Or do we? Okay, so we have, like, 0 0.5, 0 0.25, 0 0.125, 0 0.0625, right? How do we know how many zeros there are easily? Or I guess we could see how many 10s we had to multiply it by in order to make it disappear. Okay, so to multiply, okay, so we can multiply 110, 110, 110, but if we multiply 16 by 110, that is not enough. So we need to see how many 10s we can multiply it by. So we have like 5 to the 5 over 2 to the 15. Is that good enough? How about 5 to the 6? What is that? So that is just 125 times 125. Holy moly, that is nasty. Okay, well, we'll just do it for the greater good, okay? So that is 216, okay, and 0, 0, 5, 2, 0, 0. 5, 2, 1, okay, 5, 2, 6, 1, 5, 1. Okay, so 1, 5, 6, 2, 5, and 2 to the 15 is like 2048 times 16, right? Which is what? So we got 8, 4, 8, 2, 2, 2, 1, right? Dang, that's interesting. Okay, I did not know that. Then we got a 0, 8, 4, 0, 2. 3, 2, 7, 6, 8. Okay, so one more, and then we will, well, okay, 2 to the 14. Oh, so divide this by 2. So that's 1, 6 something, right? So I guess next time it'll be enough. So 5 to the 6. So 10 to the 6. So that will be how many more zeros? Okay, so this is the first time it is going to be greater than 1, right? Or no. Okay, so it's barely not enough. So 10 to the 6. Okay, how do you think about this? So 10 to the 6 is how many zeros there are before, and then you add 20, so 26. Okay. G is the answer. Alright. Okay, problem 13. Andy the ant lives on a coordinate plane. Okay, so he's currently at, what? Negative 20, 20, and facing east. Okay. He moves 1 unit, then turns 90 degrees left, then from there he moves 2 units, then 90 degrees left, 3. Okay, so it's like, your x is going to be 1, minus 3, plus 5, so on and so forth, okay? And then your x coordinate is going to be 2 minus 4, plus 6, so on and so forth. And then this is like the first move, the third move. Okay, so he makes his second move. Okay, this is his second turn, right? So his first turn, oh no, this is his first turn. So he moves and then takes his turn. So this is the first turn, this is the third turn, this is the second turn, this is the fourth turn. So if we do 2020, then we basically go all the way up to like minus, oh, so it's basically perfect. So it'll go minus 8 all the way to minus 2020. And then over here, it'll just go all the way to minus 2019. Okay, so we pair each one up, right? We pair a 1 minus 3 here, and a 5 minus 7, and so on and so forth. That'll just be negative 2 times something. And if we want to find out how many terms there are, we just do 2018 over 2, which is 1009. So the 1010 terms, right? So essentially, we just have negative 2 times 1010 times over 2, because we paired them up, so that's times 505. So that's just negative 1010. And same thing here, that's just going to be negative 1010. So we just do this minus 1010. So it'll be negative, yeah, so B seems legit. Okay. Alright, very epic stuff. Problem 14. As shown in the figure, 6 semicircles line the interior, okay? And it basically wants the area of the shaded region. Should not be too hard. I mean, that's kind of yucky, but I don't think it should be that bad. Let's see. Oh, that is kind of bad. Okay, yeah, let's just do it. What's the nicest way to do this though? Yeah, I think the nicest way literally is to just, yeah, so we're just gonna figure out like overlap areas. So what is the area of this thing right here? And then we should be good. So we know that this is gonna be radius 1, 1, and then that's a 1, right? So the area is just like the 60-degree angle. So the area of the semicircle is pi over 2, which means that the area of this segment is going to be pi over 6. And then we got to subtract the area of the equilateral triangle, which is s squared root 3 over 4. So it's just root 3 over 4. Okay, so, and then that is the area of half of this thing. So then you multiply that by 2, and you get pi over 3 minus root 3 over 2. Okay, so now we basically add up all of these circles, right? We add up all of these guys, right? But then we're overcounting the overlapped areas one time. So we basically just subtract 6 times that. So we do how many full circles? So 1, 2, 3, 4, 5, 6 half circles, which is 3 full circles, so 3 pi. And then we subtract 6 times pi over 3 minus root 3 over 2, which is going to be equal to pi plus 3 root 3, okay? And then we just need the area of the whole hexagon, and we subtract it, and we are done. So, area of the whole hexagon is just a bunch of, like, 2 by 2 by 2 triangles. I mean, equilateral triangles, right? So it's just 4 root 3 over 4, which is root 3, and then times 6, so 6 root 3 minus that, which is going to be 3 root 3 minus pi, which is not an option. Oh, it is an option. Epic! D. Alright, problem 15. How much time do we have? Oh, that's decent, okay. Problem 15, well, not that great. Okay, Steve wrote the digits 1, 2, 3, 4, 5 repeatedly from left to right, forming a digit of, okay, and he erased every third digit, okay, then erased every fourth digit, okay, then erased every fifth digit, and what is the same sum of the 3 digits that remained? Oh, so he did third, fourth, and fifth. Oh no, god dang it. Okay, so if you remove every third, then you get 1, 2, 4, 5, 2, 3, 5, 1. So basically just split up into chunks of 2. Okay, so let's just look at the original thing. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And if we split it up into chunks of 3, right? So then we basically just erase the last one of each thing. 5, 1, 2, okay? And then if we go by fours, right, then you basically just do that. Well, yeah, now it's basically by fours, so then, so now, like, yeah, so every single section is going to have 2 things left. So the fourth is just the last one of every other section. And now the fifth one is annoying, because that means that we basically take there. Oh, wait, no. Sadly, that doesn't work, so that gets erased. So now we have that is there. Okay, let's just write this out a little bit more. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so split it like that. So that gets erased, that gets erased. That gets erased, that gets erased, that gets erased. Then fourth gets erased, fourth gets erased. That's fourth. Then we go 3, 4, 5. Start there. Or fifth, that's a fifth. Wait, what? No, hold up. no, wait, what? Okay, so we need, okay, so fifth. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's do another one for good measure. Okay, divide it up. Okay, so divide that. Okay, and then we basically take out the second one from every other one, right? And then now we had to take the fifth from what remains. Oh. So I guess you just have to see how many things are removed before those positions, right? Or what position goes to 2019. So let's see. So essentially, if you take an initial position of like n, right? Then you basically just take n divided by 3. So n minus n over 3, right? And then this whole thing minus n minus n over 3 over 4. Oh, so, okay. So, it repeats every, oh yeah, we had to do out, 4 times 3 times 5, so 20 times, 60? Shoot, we had to do 60? Okay, hold up. Wait, no, this is not gonna work. I can't do that. Okay, we'll come back to it. Bella and Jen play the following game on the closed interval 0 to n on the real number line when n is fixed integer greater than 4. They take turns playing, with Bella going first. At his first turn, Bella chooses any real number on the interval 0 to n. Thereafter, the player whose turn it is chooses a real number that is more than 1 unit away from all numbers previously chosen by either player. And once you choose another, okay, so you have 0 to n, okay, and then you basically had to choose a number such that you will likely have a number to choose after they do, right? So essentially, if we choose a number here, right, on the edge, then they could choose any number here. So what is the optimal strategy though? So if you put a thing there in the middle, you're getting rid of 2 things for your player. Oh, okay, so I see. So there's basically 2 options to play, right? You can either play you can either get rid of two things, or you could get rid of one thing, right? You could get a thing of length 2, or you could get rid of a length 1 thing. Or I guess you could get anything in between, but that wouldn't really make sense. So if it's even, then, oh, I guess you could do like the odd thing. So let's say I choose here and I choose that, right? Then it's 2. Then essentially, like, the other person could always choose something such that the number is like about 3. You can make it exactly 3, right? Or can you make it always 4? Well, you can't always make it 4, because if you put here, then it will only be 1, and then you can maximum add 2 more to that. So I guess Bella, what would Bella do? So essentially, if she does at the end, and then Jen always does at the end. Wait, we need to make an invariant though, right? So what is an invariant you could do? Wait, so can't Jen always mirror her opponent? Oh, no, not always, I guess. Oh, wait, yeah, that's so smart, right? Okay. Basically, the point is, what Bella could do is she can always put it at the very center, right? Then, Jen has to put it on this side, but then no matter where Jen puts it, Bella can always mirror her move, right? So, oh, that's so big brain. Okay, so I guess it's just A then. Alright, that makes sense. A, epic. That's kind of big brain, okay. Problem 17. There are 10 people standing equally spaced around a circle. Each person knows exactly 3 of the other people. Okay. The 2 people standing next to him and the opposite dude. And how many are whether they're split into 5 pairs such that the members of each pair know each other. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So essentially, we basically want to pair this guy, could either pair with this guy, or this guy, right? Okay. Then if these two guys pair, then this guy has to pair with this guy or this guy. So say pairs with this guy, right? Or, oh, wait. So I guess we could just list them out. It doesn't seem that big. Okay, so let's just do case by case on this one guy. Okay, so that's one case. So this guy could either be like that or like that. So that's 2. Well, okay. Okay, so let's just say that this guy chooses this, right? Well, if everybody just chooses opposites, then there's one way, right? So there's one way if everybody chooses opposite dudes. Then, let's say that everybody chooses opposite dudes except, well, this guy has to choose, so the last 2 guys don't choose it, so then we could do pair, 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 and then these 2 and these 2 are paired, right? So that's another one, okay? Then, if we back it up another one, then we could, like, this guy could be paired with the next dude, so that will be another, and then this guy has to be paired, so that's another option, okay? Then what happens if these 4 dudes, so in this case, we basically need this guy to be that way, and then the only other option, okay, so then these 2 guys could either be together or they could be opposite side. Okay, so that is another 2, right? When this guy is like that. Okay, and now we've exhausted everything for this case. So now the next case is if this guy pairs like that, then let's say everybody chooses opposites, right? That's another way, okay? And then we basically just do the same idea. So plus 1 plus 2, right? Except now it's not necessarily, now it's not necessarily mirrored though. This guy chooses like that. Wait, hold up. There must be a smart way to do this. Okay, so essentially it's like a polygon with all the diameters drawn, right? So we do that. That was 1 plus 1 plus 1 plus 1 plus 2 is what we got, right? For this guy being a line. Then if this guy's a line, then we could do, okay, do we need at least one line? Okay, let's just say everybody is a line, right? Or nobody's a line, then there's one way to do it, right? You just do every other. Well, there's 2 ways to do it then, so that's 2. So plus 2 for no lines at all. If one person's a line, then we could just multiply this by who the line is. Oh, but no, but that would overcount by a lot. Well, oh, wait. No. How do you do it with lines and stuff, though? Okay, let's just see. Okay, so if this is the case, then if this guy's a line, then what other options do we have? Then this guy could be line, but these 2 guys can't be, so this has to be a line, right? And then we have that there's 2 options, right? Either this guy's a line or it's a cross. So that is 2 options, alright? Then if this guy's not a line, it's like that, then this guy could be a line. In which case the remaining 2 have to be lines as well. Okay, so that is plus, that's a line, and this is, yeah, in which case those have to be, so that's another 1. And then if this guy is like that, then we're basically done. Everybody else has to be lines. Okay, and then we have to multiply the second part times 2, right? Because it's going to be the opposite direction. Okay, so whatever this is should be our answer. So 4 plus 8 plus 6. Everything's symmetric, right? Oh, except the all lines one. What's the all lines one should not be. Everything but the all lines one should be not symmetric, right? Oh, no, that's not true. Okay, that seems legit. Okay, so 14 should be good. Alright, D it is. Alright, an urn contains one red ball and one blue ball. A box of extra red and blue balls lie nearby. Okay. He draws from the urn at random and then takes a ball of same color from the box and returns those two matching balls. Okay. Okay, so we basically want to add. So he does it 4 times, right? So we want to add 2 blue balls and 2 red balls at some point, right? So somehow we have to add 2 blue balls and 2 red balls. So there are basically 2 options at every point, right? You could either do red, blue, right? Then you could either do red, blue. Okay, so let's say this red is blue. So essentially, we always want it to be like you only want to ever add 2 blues or 2 reds, right? So if you do that, then you have to do that. Then it has to go red. Well, there's 4 choose 2 ways to do it, so we could just go through each option, right? So let us say that you want to do. We only had to go through 3 because it's symmetrical, right? So we could do R, R, B, B, R, B, B, R, and R, B, R, B. And then the other way will just be the opposite. Okay. So this is all the ones starting with R, right? Are there any other options? No, that should be good. So this one, there is a 1/2 probability of getting an R, then there's a 2/3 probability of getting R, then the 1/4 probability of getting a blue, then there is a 2/4 probability of getting a blue. Or 2/5. Then this one is going to be 1/2 probability times 1/3 probability times 2/4 probability times 2/5 probability, okay? Then this is going to be 1/2 times 1/3 times 2/4 times 2/5. No, 1/5. Because there are 3 reds, right? Okay, wait, what? No, there should be 2 at this point. Okay, 2/5. So the numerator is always 4, and the denominator is always. Oh, okay, that makes sense. So it's just like 4 over 2 times 3 times 4 times 5 times 2. Because you could also do it with starting with blue. So that should just be that 1 over 15. No, that's not even a probability. Wait, what? Okay, hold up. So you have 1/2 times 1/3, right? Am I trolling? Wait. Oh, times 3 because there. Oh, we could just do times 6 from here. Oh, okay. So 24. Oh. So that'll just be like that. So 1/5 is the answer. Nice. Yeah, basically like each probability is 4 over this, right? So you have to multiply that by 6 because there's 6 options for this. In a certain card game, dude, why is there so much combo? What the heck? Okay. A player is dealt a hand of 10 cards from a deck of 52 distinct cards. The number of distinct hands that can be dealt can be written as that. What is the digit A? Huh. What are we supposed to do? Can we just do like mod 100 or something? Huh. So they're all distinct. All 52 are distinct. So how many? So it is 52 choose 10, right? Is that wait, what? Is it not just 52 choose 10? Okay, so it's basically just 52 choose 10, and we need to find a way to find A. So we can mod it by, okay, we'll see. That's kind of nasty though. 52 times 51 times. Could we just like check if it's divisible by something? Okay, let's just write it out. So 50 times 49 times 48 times 47 times 46 times 45 times 44 times 43 times 41. 40 times 42 times 41. No, what? Oh, you only need till 43. Okay. And then there's just over 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Okay. So, what goes away? 10 with 50, we could do 10 times 5 is 50. Then we have, we could do 8 times 6 is 48. Then we'll have to be a little bit smart about the rest. So we could do 9, this is 5, okay. Then 12. Do we have any 12 left? No, we do not. 4, this could be 13. 7, 3, so 6. We need to divide something by 6. Well, we have 3, 17. And 46, 44, we gotta do this 23. Okay. So there's only 1 5, which would make sense why there's only 1 0. Okay. Then we need to figure out whether it's divisible by 4 maybe. If it's divisible by 4, that kind of narrows it down to like 20, 40, or 80 or something. Oh, it is divisible by 4. So we know that A has to be equal to 2, 4, or 6, right? Okay, then how else could we narrow it down? We want to take a mod 100. Okay, so is it divisible by 3? It's not divisible by 3, so what's the sum of everything? 14 plus, okay, so 18 plus 3a. So this should not be divisible by 3 because there's no, like, multiples of 3 anywhere left, right? So essentially, if it was 2, wait, what? How is that even possible? It has to be divisible by 3 though then. Oh, it's 4a. Okay, 4a. So basically that rules out this, so it's either one of these two, okay? 2 or 4, so now how do we get rid of the 2 or the 4? Is it divisible by 8 though? It's not divisible by 8, so it can't be, or could it be? So you could either have 440 or 220. Which one is divisible by 8? Are either of them? Yeah, one of them has to be divisible by 8. Well, this is 2 times that, so if this is, okay, so that's divided by 4 is 55. Okay, so yeah, so this is divisible by 8, but this number is not divisible by 8, so it has to be 2. So A, very nice. 20, let B be a right rectangular prism with edge lengths 1, 3, and 4, and its interior, okay. For real R, so there's a set of points in 3-dimensional space that lie within some distance R of B, okay. Within, oh. So, is it not just like, hold up. So you have to do like this minus R, right? Okay, so obviously you're gonna have like the volume minus like this inner part, right? And the inner part is just gonna be what? The inner part is gonna be like minus 3 minus 2R times 4 minus 2R times 1 minus 2R. Okay. Oh, yeah, this is like Vietas, right? So we need roots of this. Is there an easy way to do the roots of this? So D is 0 then? Because we have this. Wait, D can't be 0. Wait, what? So am I doing this wrong? Volume of S of R. Oh, so it also includes like the outer side. So it would have to be like 3 plus R, or 3 plus 2R times 4 plus 2R times 1 plus 2R. Okay, huh. That is kind of yucky. Is there an easy way to subtract these though? Okay, so wait. We basically know that the roots are just like negatives of each other for these two things. The roots, okay, so, oh, okay, that's kind of big brain. So roots of the first one are negative 2/3, or negative 3/2, negative 3/2, negative, what? Negative 2, and negative 1/2, right? So sum of the roots is going to be negative 4. Product of the roots is going to be like negative 3/2. And then if we break it up, then it'll just be 1 plus 3/4 plus 3. So 4 plus 4 3/4 is 19 over 4, okay? And we know that A is just going to be equal to 8, right? So this is sum. So sum is going to be the first one. So 8r cubed minus or plus 32r squared. And then this is the next one. So it'll be 8 times 19 over 4 is 38. So plus 38r plus 3 over 2 times 8. So 12. Okay, and then here it'll be minus 12. Wait, no, this just can't be right though, right? Because then the constant term will be 0. Wait, what? Are you trolling? Hold up. 3 minus 2r. Oh, wait, there's rounded corners on the outside, dude. Oh no. What? Shoot, there's rounded corners on the outside. Ah, wait, this is kind of... Wait, what? No, there's no pi anywhere though. But that is not on the thing. Oh, all points in its interior. Bruh. I'm doing this all wrong. Okay. That makes a bit more sense. So, essentially, there are spheres right here, right? And basically, you could sum up the remaining rectangles. So, we'll do that. So, we could basically just do, okay, so we have like 3 minus 2r, or 3 plus 2r. What was our thing? So, we had 8r cubed plus 32r squared plus 38r plus 12, and then we can subtract the corners, which are r squared, or r cubed, right? So minus 8r cubed, and then we add in like pi r cubed for our sphere. So we have 8 times, so it'll just be pi r cubed over 4. Oh, but these are also cylinders, dude. Oh my god, dude. God dang. Okay. Oh, okay, so I guess we have to subtract the cylinders too. Okay, whatever. So pi r cubed, 4/3 pi r cubed, whoops, times 2. And then we also have to subtract out these guys. So we could do minus r squared times 1 plus 3 plus 4 times 4 plus pi r squared times 1 plus 3 plus 4 times 4. Okay, so that gives us minus 32r squared. Oh, okay, so this just cancels out right here, and this cancels out there. And essentially, we are left with 4 pi, or no, what am I doing? Yeah, 8 pi, or we don't multiply by 4 because these are like fourth cylinders, okay? So 8 pi over 3, what is this? 13 pi, r squared, plus 38, r plus 12. Okay, so b times c, 13 times 38 over 12 times 8, and 3 in the numerator. No, that's not right. It is right. This r. Okay, so it's 3 plus 2r. Okay, so you want to do 3/4 plus, or 3/4 plus 1 plus 3. 13 wrong? Maybe 13 is wrong. So we have length 1, length 3. Oh, that's 8. How did I get 13, dude? What the bruh? Okay, so that makes a bit more sense. So then, essentially, what was this? 12. I mean, that still doesn't work, right? Okay, well, at least this cancels out now. And then this, oh, so 19 over 2. Well, okay, I'm assuming I missed a 2 somewhere, right? Or did I get an extra 2? So it's for sure 12, okay. And then 8. Oh, maybe the 4/3 pi r squared. So pi r squared. Oh, these are all 8 spheres. Okay, so yeah, it is 19. Alright, that took so long, god dang it. 20 is B. I probably should not have spent so long. How much time do we have? 60 minutes for the last 5 is not good. Okay. Alright, so we have a square ABCD, and we have E and H here, and we have JGIF, okay, AE is equal to AH, okay, FI, okay, so each thing has area 1, FC, okay, so this has 1, and this has 1. 1, 1, 1. So what is the silence of the square though? Oh, it doesn't tell us. Okay, seems legit. Okay, so basically we need a way to find the area of the pentagon. Alright, so let's just say it is R, right? So then there's like, does it say what the silence of the square is? It does not. Huh. Oh, they all have area 1. AEH also has 1. Oh, okay, that makes it a lot easier. Okay, so we know the silence of the square is 2, so then there's 2 minus R, and then, what else do we know? Then this is gonna be, like, I don't know, what? Well, we need some way to find out this thing here. Okay. Well, okay, so if this has area 1, then we know that this has to have root 2, okay. And if that has root 2, we could probably find the, what could we find? Well, what's the best way to break up these, or, Oh, okay, so we know that this is r root 2, right? So we basically have, oh, but how do we find this, though? Oh, but we can find the intersection points, right? 2 minus r, 2 minus r. So that means that this overlap is going to be 2 minus, like, or 2 plus r, or, oh, so r minus root 2 is just this overlap. Oh, no, it's just going to be root 2 minus. Because you increase r, the overlap should decrease, right? So r root 2 minus r, right? So it's going to be, yeah, okay, that makes sense. So root 2 minus r is the overlap. So that means that this distance is just going to be 1 minus r over root 2. Or, oh, wait, so this is just 2 minus, so this is just going to be 2 minus r root 2 minus 1 minus r over root 2. Because this is also going to be 1 minus r over root 2. In which case, we basically have 2 root 2 minus 1. That's kind of nasty. Or, so you add, so it's like 3 root 2 over 2r minus plus 2 root 2 minus 1. And you basically want this whole thing to have area. Wait, this is nasty, dude. Hold up. Seriously? I mean, I guess so, right? Okay, so this is that. Which essentially means that the area is going to be times r root 2 plus r squared over 2 is equal to 1. Which basically gives us 3r squared plus 4r minus root 2r plus r squared over 2 is equal to 1. Wait, no. I'm doing something wrong. Hold up. Maybe we could solve for fj. Maybe we could call this x. Oh, maybe we should just do that instead of doing all. Okay. Because we only had to solve for that squared. Okay, so we call this x. This is going to be like, okay, so we know that if this is x, then like, what do we even know though? Can we even get anything in terms of x though? Oh, but we know this length, right? This length is going to be 2 root 2 minus 1. No, 2 root 2 minus 2 because of that. No, 2 root 2 minus 1, okay. So essentially we have x plus 2 root 2 minus 1 over 2 times the height, which I guess we would get like 2 root 2 minus 1 minus x times 2 root 2 minus 1 minus x. Because that gives us this part. And then this times 2 is equal to 1 because of trapezoids. Okay, so that's a difference of squares. So, so we're almost done. Okay. So then we basically have this squared minus x squared is equal to 1. So we basically get x squared is equal to 2 root 2 minus 2, or 2 root 2 minus 1 squared, and then minus 1. So if we factor that out, then we basically get 2 root 2 minus 2 times 2 root 2, because it's the difference of squares, is equal to x squared. So this just becomes 8 minus 4 root 2, which is B. Holy, god dang it, I'm so rusty. Alright, B. Okay, 22. What is the remainder when 2 to the 202 plus 202 is divided by 2 to the 101 plus 2 to the 51 plus 1? Okay, so basically we got to get as close to that as possible without going over. So let's just say we do 2 to the 100 times that, right? So we basically do 2 to the 201 plus 2 to the, we're multiplying by 100, right? So 151 plus 2 to the, well, we know if we do 2 to the 202, then it's too much, right? Yeah, so we multiply it by another 2, then that's just going to be too big, for sure. But this is for sure too small, okay? So this is just 2 to the 100, okay? So if we subtract this, we basically get 2 to the 201 minus 2 to the 151 minus 2 to the 100 plus 202, okay? And now what happens if we like try to get this again? So we do 2 to the 99, let's say. So now we have 2 to the 100, or 2 to the 200 plus 2 to the 99, so 60 plus 90, 150 plus 2 to the 100. If we subtract these again, then we get 2 to the 200. No, that doesn't seem like it would work, right? Could we like get rid of some factors somehow? So if we do 2 to the 100, okay, let's say we do 2 to the 100, then that's going to be 2 to the minus, like, I don't know. Okay, so this is going to be 151, so we want to make the next one 151. Or actually, let's do 101, okay. So then this is going to be 2 to the 152, so we want to get rid of the 152 somehow. Minus 2 to the 51, right? So then this is going to be 2 to the, subtract, so it'll be minus 2 to the 102. Oh, okay, so this right here is going to be 2 to the 2 to the 202, so that cancels out, minus 2 to the 102 plus 2 to the 101 minus 2 to the 51. Okay, wait, really? Okay, yeah. So then this becomes 2 to the 202, like minus 2 to the 101. Wait, really? Oh, really? Huh. Okay. Wait, I think that doesn't really matter. Okay, 2 to the 51, okay. Oh, wait. Okay, so this is a multiple of this, right? So essentially, this right here is like 2 to the 101 plus 2 to the 51 plus 202 more than this, right? And we know that this could go into this once, so, or 202, so the answer is just 201. Oh my god, that's big brain. Okay, 22 is D. Okay, we only have 2 minutes, 51 seconds. Do we dare do the next one? Let's see. Considering 4 transformations, I don't even have time to read these. Okay, these are probably nasty. Let us just try 15 for the last few seconds, and then hopefully we can get that. Okay, and then fourth. So this guy gets deleted, then fourth gets deleted, then that gets deleted, and then 1, 2. Yes, this guy would get deleted. And it would keep changing for like 12 times though. Oh, we did get to 12. Oh. Alright, so I don't think we're gonna get that, so why don't we just check what we have, okay. Bruh, I'm actually so rusty, god dang it. Okay, let's see. Alright, D, E, E, D, B, B, A, D, D, C, D, D, B, D, did not do 15, A, D, oh no, we got 17 wrong, god dang it. 18B, 19A, B, B, D. Okay. So essentially we got 21 right, so that's 126. And then we got 1 wrong, so we got, how many do we, I don't know, we got 20 right, so that's 120. And then we left, how many did we leave blank? We left 4 blank, or no, yeah, 4 blank. So plus 4 times 1.5, so 126. Ah, that's so bad. Oh god dang it. Okay. I mean, it's not great, but it's passable. Okay. God dang it. I need to practice more. This is so sad. Okay, let us see what we did wrong for 17. Oh, what is this one? Ah, god dang it. I hate these. Yeah. I don't know. Maybe it was. I don't know whether it's nasty casework or whether there's a better way to do it. Huh, maybe you could do casework on based on like how many lines there are, right? So let's just say there's 1 line, right? So if there's 0 lines, there's 2 ways to do that, right? You could do this like that, or you could do the other alternating ones, right? Okay, then if we have only lines, right? Or no, we could have 1 line, right? Then we know the remainder have to be like that. And there are, whoops, not like that. And then the remainder have to be like, I mean, there's basically 5 ways to choose the line, so there's 5 ways to do that. Okay, then if we do 2 lines, right, we do that, is that right? No, hold up, like that. Then essentially, if we make the second line like that, you have to have a third line. There's no way to, okay, yeah, you have to have an odd number of lines. Yeah, you have to have an odd number of lines. So let's say you have 3 lines, right? Then essentially, is there any way to choose it? Okay, so you can basically choose 3 lines in any ways, as long as they don't split it up every other, right? So if you do, like, so the only way to choose 3 lines that doesn't work is like that. Because then these guys cannot form a pair, but everything else works. So how many lines are there? There's 5 possible lines, so you do 5, choose 3, and then minus 1, right? Which is 20, or which is 10 minus 2, which is 8, okay. Wait, what? That's already too much. Hold up. Oh, but yeah, they can't start at the same, yeah, okay, so how many ways are there to choose 3 lines that are disjoint? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's just say we fix this line, right? Then the next 2 lines basically have to be adjacent to each other. So, well, actually, let's just see. So there's 4 ways to choose the next line, or, okay. Oh, I see. So, okay, so we basically just choose 1 point, and then it automatically goes to its opposite neighbor. So, okay, so you could do these 3. You could do, so there's basically only 5 ways. You could just rotate this around. There's no other way to do it. Okay, so plus 5. And then the only other option is 5 lines, in which case there's 1 way to do that. So you get 2 plus 5 plus 5 plus 1, which is 13. Okay, so that's what I did wrong, so that's C. Alright. So what about 15? How do we do 15? I'm going to solve that, and then I'm going to end the video. How about that? Okay, so I think what we realized is that, like, after you delete this and that, then basically the first 2 are sets of 4, so you always end up deleting the 4th guy in these sets, right? So this guy gets deleted, that guy gets deleted, and then now you basically have alternating things of 2s and 1s, sets of 2s and 1s. So you have 2s, 1, 2, 1, and then this is a 5, then the next one is going to be not 5, though, it'll be 2, 1, it'll be 1, 2, 1, 2. Well, I guess after that, then it'll be like 1, 2, 1, 2. So you basically split this guy in half, and then the other 1, 2, 1, 2 every thing. Huh? Maybe there's a pattern or something. Let's see. So it becomes 1, 2, 4, 5, 7, 8, 10, 11. Then it becomes 1, 2, 4, 7, 8, 10. And then when you delete every 5 is the problem. So basically the idea is we want to end up at 2020, right? So if we go backwards, we know that like it's n minus n over 5, right? Because if you delete every 5th, then this guy gets shifted over because 1 guy before him got deleted. Okay. So like if you plug this in, right, 6 minus 6 over 5 is just going to be 6 minus 1 is equal to 5. So yeah, 6 slides into the 5th position. So we want this to equal 2020. And I'm pretty sure you have to like times 5 over 4, so it's around 2525. But that's a multiple of 5, so the original position should be 2524 before we delete the 5th digits, okay? Then essentially we need something that's like 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And essentially we're deleting the 3rd and 4th guys. So let's divide it up in every 3rd, right? Or not every 3rd. well, that, okay. Then essentially we delete every third, okay. Then we delete every fourth. So that would be this one and that one. Okay. So essentially, like, every three in the new thing corresponded to 6 in the old thing. And then it's like the same thing. So if we divide this by 3, what do we get? So 8, 1, 2, 4, then 1, and this becomes the remainder 1. So it's 841, remainder 1, okay? So you can see, right, like, if this is 4, right, it's quotient 1 and remainder 1 when divided by 3, so you multiply by 6, get 1, and you realize that this is at the 7th position originally. So our, what? So essentially we get, like, 6 times 841 plus 1, right? So that is just going to be, like, what? 64250, okay, so 5047, okay. So that means that is just gonna be like position 5047, okay. Then what about if we do 2 3, then it's gonna be 0 mod, right? So that means it's gonna be one of these guys. So it's gonna be like, it's in the 841st, or yeah, so it's gonna be in the 841st. Okay, so let's see. There's 841 of these sections, right? So it's gonna be here plus like 4. So this is 0, and then you add plus 4. So 840 times 6 is gonna be 5040, right? And then you add 4, so that's right. So we have 5047 corresponds to 2 mod 5, plus 4 is 4, then plus 2. And now the last one, we know that, like, the thing that translates to 2021 is 2526, which is going to be mod 3, or, wait, what? No, so then this is going to be 2. Okay, so that's a 0 again. So once again, it'll be 841 times 6, so this plus 4. So it'll be 0 mod 5, which corresponds to a digit 5, so plus 5. And hooray, oh yes, okay, so then we get 11, and is that our answer? I think it was D, right? Hey, very epic. Okay, alright, thank you guys so much for watching. If you guys want me to go through the last 3 problems, I will go through them in a separate video, but that's all I got for you today. I'm kind of rusty, so I'll try to, hopefully I could do a bit more, like, you know, full live solves in the future, but this is what I got for you today. So anyways, thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Thank you guys so much for watching again, and see you guys next time.